Hello guys, this is OKC Chedese from Special Maths Academy. In this video, we're going to be solving question 6 of 2021 Senior Maths Olympiad first round. We're told to find the sum of the roots of two polynomials p of x and q of x. P of x is defined to be 2x squared minus x minus 1, and q of x is defined to be 2 minus x squared minus x. Then we're told to find the sum of roots of p of x and q of x. If you are told to find the sum of the roots of a quadratic polynomial, you don't have to start looking for what the roots are and add them up to get the sum of the roots. There's a better way of going about that. So let's say we have a quadratic polynomial now. Let's say f of x. And f of x is ax squared plus bx plus c. Then the sum of the roots of this quadratic polynomial is going to be equal to, so let's say the roots are r1 and r2. The sum of the roots will be minus b over a. So is this easy to get it? Just minus the coefficient of x divided by the coefficient of x squared. You don't have to start looking for what the roots are and adding them together, no. So this fact is actually part of a larger theorem. You want to look this up too. You want to look at Vetter's theorem. So Vetter's theorem is a theorem that relates the sum of roots and products of roots and all those things of a polynomial. You can check that out. So we'll continue the question now. So let's say the roots of p of x now are a1 and a and b, and the roots of q of x are c and d. We'll start by looking for what a plus b is. So we have that p of x is 2x squared minus x minus 1, and therefore the sum of the roots, which is a plus b, is going to be minus the coefficient of x, which is minus 1 from here. So that will be minus 1 divided by the coefficient of x squared is 2. That's over 2 here. And therefore the sum of the roots of p of x is going to be 1 over 2. And for q of x, it's a similar thing that we're going to do here too. Q of x, we're told that it is 2 minus x squared minus x, and the roots are c plus d. Sorry, sum of the roots is c plus d. And then this is going to be same thing again, minus. And the coefficient of x here is minus 1. So that will be minus 1. And the coefficient of x squared here is also minus 1, since we have minus x squared. So that will be minus 1 over minus 1. And this becomes minus 1. And therefore, the sum of roots of p of x is going to be 1 over 2. And the sum of roots of q of x will be minus 1. And the sum of roots of both polynomials, which is a plus b plus c plus d, is going to be 1 over 2 plus minus 1, which is 1 over 2 minus 1, which is minus 1 over 2. So the sum of the roots of these polynomials p of x and q of x is minus 1 over 2.